determine the total number of duplex outlets permissible on a 20-amp branch circuit, it's essential to adhere to the National Electrical Code, specifically referencing the 2005 NEC Article 210.8-3. This code provides guidelines for electrical installations, ensuring safety and proper functioning of electrical systems. The core of calculating the number of outlets lies in understanding the amperage requirements per outlet. The NEC mandates that branch circuits serving lighting and receptacle outlets be sized with a minimum of 1.5 amps per outlet. This 1.5 amps figure is crucial for standard 120 volts duplex outlets. To clarify, each standard duplex outlet is considered to draw 1.5 amps for calculation purposes. Given this requirement, a simple formula is used to determine the maximum number of duplex outlets that can be safely installed on a 20-amp branch circuit. This formula is expressed as total outlets equals circuit ampacity divided by 1.5. Here, circuit ampacity refers to the total amperage of the branch circuit, which in this case is 20 amps. To illustrate this with an example, consider a 20-amp circuit. Applying the formula, we divide the circuit's amperage, which is 20 amps, by the amperage requirement per outlet, which is 1.5 amps. This calculation is expressed as total outlets equals 20 amps divided by 1.5. Performing this division yields a result of 15.33. However, in practical electrical installations, it is not possible to install a fraction of an outlet. Therefore, it is necessary to round down the result to the nearest whole number. Rounding 13.33 down gives us a whole number of 13. Consequently, a 20-amp branch circuit can safely support a maximum of 13 duplex outlets. It is important to note that this calculation assumes standard usage scenarios and does not account for specific loads that may draw significantly more current. For instance, if any of the outlets are intended to supply power to high-demand appliances or equipment, it may be necessary to reduce the number of outlets and the circuit accordingly. In such cases, a load calculation should be performed to determine the actual current draw of the connected devices. Furthermore, it is crucial to adhere to all other applicable codes and regulations when designing and installing electrical circuits. This includes considerations such as wire gauge, conduit fill, and overcurrent protection. Consulting with a qualified electrician is always recommended to ensure that the electrical installation meets all safety and code requirements. Now let's delve a bit deeper into the factors influencing the number of outlets on a circuit. Firstly, consider the wire gauge used for the branch circuit. The wire gauge must be appropriately sized to handle the anticipated current load. The NEC provides tables specifying the allowable ampacity of different wire gauges based on their insulation type and installation method. Using a wire gauge that is too small can lead to overheating and potentially create a fire hazard. Secondly, the overcurrent protection device, such as a circuit breaker or fuse, plays a critical role in protecting the circuit from overloads and short circuits. The overcurrent protection device should be sized appropriately to match the ampacity of the branch circuit. In this case, a 20-amp circuit requires a 20-amp overcurrent protection device. Thirdly, the type of load connected to the outlets can significantly impact the overall circuit capacity. While the NEC specifies a minimum of 1.5 amps per outlet for general-purpose receptacle circuits, certain types of loads may draw significantly more current. For example, appliances such as hair dryers, space heaters, and power tools can draw 10 amps or more. If multiple high-demand appliances are connected to the same circuit, it may be necessary to reduce the number of outlets in the circuit or to install additional circuits to accommodate the load. Fourthly, consider the potential for future expansion. It is often prudent to design electrical systems with some degree of spare capacity to accommodate future needs. This may involve installing additional circuits or increasing the size of existing circuits. By planning for future expansion, you can avoid the need for costly and disruptive electrical upgrades later on. Fifthly, understand the concept of continuous load. The NEC defines a continuous load as a load that operates for 3 hours or more at a time. For a branch circuit supplying continuous loads, the maximum load is limited to 80% of the circuit's ampacity. This means that a 20 amp circuit supplying a continuous load can only be loaded to a maximum of 16 amps. This deterring factor is intended to prevent overheating and ensure the long-term reliability of the electrical system. Sixthly, it is important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a long circuit is significantly lower than the voltage at the source. Excessive voltage drop can cause appliances to operate inefficiently and may even damage them. To minimize voltage drop, it is important to use appropriately sized conductors and to keep circuit lengths as short as possible. The NEC provides guidelines for calculating voltage drop and recommends limiting voltage drop to a maximum of 3% for branch circuits. Seventhly, ground fault circuit interrupter or GFCI protection is an important safety feature that is required in many locations such as bathrooms, kitchens, and outdoor areas. GFCI outlets are designed to detect ground faults, which can occur when electricity leaks to ground. When a ground fault is detected, the GFCI outlet will quickly trip, interrupting the flow of electricity and preventing electrical shock. The NEC specifies the locations where GFCI protection is required. Eighthly, arc fault circuit interrupter or FSI protection is another important safety feature that is designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. FSI breakers are designed to detect arc faults and to quickly trip, interrupting the flow of electricity and preventing fires. The NEC specifies the locations where FSI protection is required. Ninthly, ensure compliance with local codes and regulations. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. It is important to be familiar with these local requirements and to ensure that all electrical installations comply with them. Local codes may be more restrictive than the NEC in some cases. Tenthly, seek professional guidance when in doubt. Electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of an electrical installation. A qualified electrician can provide expert advice and ensure that the work is done safely and in compliance with all applicable codes and regulations. Now, let's consider some specific scenarios and how they might affect the number of outlets you can install on a 20 amp circuit. Firstly, imagine you are wiring a home office. In a home office, you might have a computer, a printer, a monitor, and a few other electronic devices. While none of these devices individually draw a large amount of current, the cumulative load can add up quickly. In this case, it would be prudent to install fewer than 13 outlets in the circuit to ensure that there is sufficient capacity for all of the devices. Secondly, picture yourself wiring a kitchen. In a kitchen, you have a variety of appliances that can draw a significant amount of current, such as a microwave, a toaster oven, and a blender. The NEC requires that kitchen countertop receptacle outlets be served by at least two 20 amp small appliance branch circuits. This requirement is intended to ensure that there is sufficient capacity to handle the high demand of kitchen appliances. In this case, you would not be able to install 13 outlets on a single 20 amp circuit. Thirdly, consider wiring a bathroom. Bathrooms have specific requirements for GFCI protection and for the location of receptacle outlets. The NEC requires that all receptacle outlets in bathrooms be GFCI protected. Additionally, receptacle outlets are required to be located within 3 feet of the outside edge of each basin. In this case, the number of outlets is likely to be limited by the physical space and by the specific requirements of the NEC. Fourthly, envision wiring an outdoor area. Outdoor areas are subject to harsh weather conditions and require special considerations for electrical safety. The NEC requires that all receptacle outlets in outdoor areas be GFCI protected and that they be weatherproof. Additionally, it is important to use appropriate wiring methods and materials that are designed for outdoor use. In this case, the number of outlets may be limited by the available space and by the specific requirements of the NEC. Fifthly, think about wiring a garage. Garages often have a variety of power tools and equipment that can draw a significant amount of current. The NEC requires that garages have at least one receptacle outlet in addition to receptacle outlets for specific equipment. It is important to consider the potential load of these power tools and equipment when determining the number of outlets to install on a circuit. It is also crucial to understand the concept of demand factors. Demand factors are used to reduce the calculated load for certain types of occupancies and equipment. For example, the NEC allows a demand factor of 75% to be applied to the total calculated load for dwelling units. This means that you can reduce the calculated load by 25% when determining the size of the service entrance conductors. Demand factors are based on the assumption that not all of the electrical equipment in a building will be operating at the same time. By applying demand factors, you can reduce the size of the electrical service and save money on installation costs. However, it is important to use demand factors carefully and to ensure that the calculated load is sufficient to meet the actual needs of the building. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical systems. It is updated every 3 years to reflect changes in technology and to address new safety concerns. It is essential for electricians, contractors, and homeowners to be familiar with the NEC and to comply with its requirements. Failure to comply with the NEC can result in fines, penalties, and even legal liability. In addition to the NEC, there are also a number of other organizations that develop standards and guidelines for electrical safety. These organizations include Underwriters Laboratories or UL, the Institute of Electrical and Electronics Engineers or IEE, and the National Fire Protection Association or NFPA. These organizations develop standards for electrical products, equipment, and installations. By following these standards and guidelines, you can help to ensure the safety of electrical systems and prevent electrical accidents. Electricity is a powerful and potentially dangerous force. It is important to treat electricity with respect and to take all necessary precautions to prevent electrical accidents. By following the guidelines of the NEC and by consulting with qualified electricians, you can help to ensure the safety of yourself, your family, and your property. Remember, safety is always the top priority when working with electricity. Finally, to reiterate, always consult the latest edition of the NEC and local codes for the most up-to-date requirements and regulations. Electrical codes are subject to change, and it is essential to stay informed to ensure compliance and safety.